Well, hello, and good after. Okay, I don't actually know when you're watching this or when you're doing this, so it could be in the morning, it could be in the middle of the night. Maybe we're having a hard time sleeping and my voice lulls you to sleep. Huh. Well, so be it. There we go. Let's move along. Let's do some math here. All right, so when you're doing this math thing, I want you to keep an eye on that pause button, and I want you to hit pause a lot, okay? A lot of pausing, because I want you to do your math and then check it with my math. So don't watch me do math. Okay, that's no fun. Don't be just watching me do math, but you do some math and check it with my math, and let's see how math went. I said the word math a lot. So there you go. We're going to move along. Let's do some, what's that thing called? Yeah, let's do some math. All right, but press pause. You do it first, and then check mine. We're doing a little matchy-matchy. All right, number one, let's run through these real quickly. Well, we don't have to be fast. I'm not in a hurry. And it could be in the middle of the night there. So let's say x plus 5 equals 20. So I'm looking for one that has to do with addition, and that's exactly what A is doing. I have some, and I added 5 more, and end up with 20. So that first one goes with A. This next one is multiplication. This is saying 5 sets of x is 20, and that's definitely what's going on with B. B is 5 sets of x. So when I'm doing multiplying and dividing, it's going to look like these pieces, these individual pieces. Adding and subtracting is going to end up with 1 or 2 pieces probably not equal in length or something like that. Okay, the third one here, we got another multiplication. This is saying 5 sets of x, so that goes with B. This next one, 5 plus x is 20. That's A. It's just written in a different order because of the commutative property. You can flip the order on and get the same thing. This next one is division. Multiplication and division are friends. This is saying I have 20 and I'm dividing it into 5 groups, and I should be able to get the value of x. That's definitely a B thing because, again, multiplying and dividing are friends. They get along. They're like more like siblings, actually. So they actually don't always get along. But anyway, so and this last one is subtraction, which is like A. So it's like the sibling of addition. So they do get along mostly. Like, yeah. Let's do this. Lynn had $22, and she made a salad, or she bought a salad for a certain amount of money, and now has 11.50 cents left. Okay. I wonder what kind of salad she got. What kind of dressing Lynn likes. All right, so let's look at the first one. So the first one's saying 11.50 plus the unknown amount should get us the amount we started with. Yeah, that's true, because if I have my change and I add how much money was spent, I should get my total I started with. So A totally works. B is saying my $22 plus the amount I've spent should get me 11.50. That is not true. Yeah, because then x has to be like a negative number if we're getting smaller. Yeah, that's not a thing. Well, I mean, I guess it could be if we're adding a negative number, but we're not doing that yet. That's not a thing we're into right now. Let's move on to C. I have $22 and I'm spending some money and I land at 11.50. You know what, that works. That's exactly the story that's going on. D, looks like we have multiplication going on here. 11.50 times x. Yeah, that is a thing, but just not in this situation. If she's buying multiple salads, that would work for this one. And for E, it's division, which we also did not do. If she's sharing her salad with people, or if she's dividing it up for other days, that would also work, but not in this situation. She had some money, and she spent it. That a girl. Let's do this one. Why don't you press pause and give it a try. Sandra had 7 bracelets. Okay, so that's important. Made each are x inches long. Okay, and she put them all together, and they measure a total of 45 inches. All right, we're just gonna do this. So 45 inches, that's my total, divided by an unknown length should get 7. So it's 45.5 divided by an unknown length of each one should get 7. Yeah, we got end to end. Yeah, this is gonna work. Like, that works right there, because we have 7 of the same thing, which does feel like multiplying and dividing. So that means B with addition. That's saying I have 7 bracelets plus even more bracelets, but yeah, we're not doing that in this scenario. This is 45.5, so this is saying I have, that's how many inches, and I'm subtracting bracelets. I don't really subtract bracelets from inches. That's not a thing. This guy here's multiplying. This is saying I have 7 bracelets of an unknown length, and when I multiply them together, I get the total. That totally works. And this one's saying I have my total divided into 7 groups, and I should get x, which also works. let's move along here. Whoa, what are these things? Yeah, we got some hangers, some mobiles. They're hanging right here, and this little line represents an equal sign, so that's going to be equal. So let's make one side equal to the other. So this first one, we have a y and a y, so 2 y's. So once I know what y is, I'm going to double it. So 2y is equal to 8.2. That is the equation. And we could find the value of y by taking 8.2 and dividing by 2 and get y. But we're not going to do that right now. Let's go to this one right here, this mobile, this hanger. I have 3 x's, which is literally 3x, which is equal to 1, 2, 3, 4, 5, which is equal to 5. And I could solve that because I could see there's multiplication going on here, so I can solve it through division. I can take 5 divided by 3, and that will find the value of one of those x's. Let's do this one. All right, I have an x on this side, and plus, we're not multiplying this time, 2.5 equals, which is what this line is, 6.4. I could solve this one by taking 6.4 and I subtract out the 2.5. And if I subtract that, I'm going to find out what x is, because I'm going to undo addition with subtraction. Let's do D. Okay, D, I've got a Z, right? And I'm adding onto that side of the mobile 2/5, and it equals 1. So I undo addition with subtraction. So I have 1 total. I want to subtract out 2/5. And once I do that, I should find the answer to Z, the value of Z. Yes, let's move along here. What do I got here? Write an equation to represent the hanger. I feel like we kind of just did this one. So I have 2 x's. So my equation is 2x. And the hanger is equal to the other side, 2864. Yeah, there's my equation. And to undo multiplication, I do division. So 28.64 divided by 2, and I should get 14.32. And that's the value of x. And I can find that out by just checking it real quick. 14.32 doubled is 28.64. Equal. Nice job. Now let's talk about this guy. A little matchy-matchy here. All right, so in this one we have, let's see. I'm looking for, like, I'm going to do my adding and subtracting ones first. That's this one. So this guy right here, this one looks like a 10 plus 5. And do I have a 10 plus 5 anywhere over here? I do not have any 10 plus 5s. How about this one? I have a K plus 5. Do I have that anywhere? I don't have that anywhere. So with additions, friend is also subtraction, which I do see. So let's see which one goes with which. So this one here has a 15 in it, and this has a 15. So it's saying if I have 15 of something and I subtract K, I should get this value right here, which works fantastic. This one right here is saying, let's see, addition. It's going to go with subtraction. So these probably go together because it's got the 10. This is saying I have K, and I take away 10, and I should get a value of 5. That works awesome. All right, let's do this one right here. Oh, we got an equal grouping, so that's multiplying and dividing. Another equal grouping, so that's multiplying and dividing. So let's say this is this is like 3K. Do we have 3K anywhere? We do. Here's 3K. 3K equals 15. And this one right here, this is saying K divided by 3. There's the last one. It's saying if I take all of K and I divide it into 3 groups, I get 15. So we're trying to find the value of K. Yes. Go us. We're amazing at this. Good job on the matchy-matchy. We're going to write some equations. Awesome, awesome, awesome. Let's write some equations. There's not a lot of space, so I draw some lines here. Now, I'm literally going to take the words itself and turn it into an equation. So I'm going to do it on the first one. I'm going to do it right above it. So what? I don't know what is. So I'm going to give it a variable. Is an equal sign. 70%. I'm going to turn it into a decimal. Of means to multiply. 120 is 120. There is my equation. Yeah, I know. That's it. That's all you have to do. Take the sentence itself and just turn it into an equation. Let's try it on this one. So 45 is equals What percent? I don't know. That's how we give it a variable. Of, which means multiply, 120. Nice. I'm going to rewrite this too, so it looks a little more algebra-y. So 45 is, and we can write 120x. You can write both these ways, and you will get your answer. Both of those are true. All right, let's do the last one. And I'm literally going to take it and rewrite it as is, and it's going to form my equation. So 43%, turn it into a decimal, of multiplying 120 is an equal sign. What? 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 I don't know. Let's give it a variable. I'm going to give it an x. There's my answer. There's my equation. I could use a dot. I could use the parenthesis. I do need to use something, though. Now, you got this. Just keep practicing those. In fact, let's practice it another time right here. We're going to literally take it. I'm going to try to, okay, 80% of x is 45. So 80% of x is 45. Do I need to get to solve this one? Write an equation that shows relationship. All right, but you know what I would do to solve this? I would divide. I see multiplying, so you undo multiplication with division. So I would take 45 divided by 0.80. In fact, that's how I would solve a lot of these ones. This one right here, I would take 45 divided by 120. That's how I'd solve that one. What's this one? Oh, these two I would just multiply together. 0.43 times 120, and I would get x. On this one in here, oh, I would literally just multiply those together, and I would get the answer. Yes. So sometimes you're multiplying, sometimes you're dividing. But notice on all my equations, especially when we're talking about percents, they are multiplication problems, but sometimes you will use division to solve them. Oh, number 9, looks like we get to do another one. Lynn has completed 24 hours of work. Good job, Lynn. So far this week. Okay, not at one time, because that would be like an entire day nonstop working. So she spread that out over a week. This is 80% of the number of hours she's scheduled to work this week. Oh, so she was supposed to work more. So what don't we know? We don't know what she was scheduled for. That we don't know, so we're going to give a variable to that one. So we need to write our equation. So let's see. 80% of her scheduled hours, which we don't know, is 24. I believe that's my equation. 80% of something is 24. Very often students get there's a misconception here that they want 80% of 24, but 80% of 24 is a smaller number. And she was actually scheduled for more hours. So make sure you check to see if your answer is reasonable. Like really go back and look and see, is my answer reasonable? Does it fit the story? Because if you did 80% of 24, which would be 24 times 0.8, if you do that, you're gonna get a smaller number. And hopefully you would stop for a second and go, wait, that doesn't make sense. That cannot be true. But let's find out which one of these fits that. 80% of x. Oh, that's right here. There's 80% of x, and they took 0.80 and just simplified it. Oh, nice. Oh, yeah. So this is the one. That's the one. Now, how would you solve that one? Is you would, I see multiplying, so I'd solve it using division. Right? Totally true. So I would take 24 divided by 0.8, but I can't have a decimal in here, so I have to move the decimal over, which means I have to move the decimal over, and I would solve that out. I'd run my division. I'm times 8 goes into 24 and work that out. Way to go, us. Ooh, another one. Okay, look, here's my sentence. 60% of x is equal to 48. I just gotta write it. I can do this. 60% of x is equal to 48. Ta-da! There's my equation. And I solved this using division. Okay, so I'm gonna come down here, I'm gonna take 48 divided by 0.6. Now I could do 0.60, but I'm gonna simplify it and knock that 0 off to kind of keep it a little easier for me because I don't need it. Move the decimal over 1, move the decimal over 1, and put it up in my answer. And I can solve. 6 goes into 4 0 times. 6 goes into 48 8 times. With no remainder, 6 goes into 0 0 times. So let's put my answer in here as x equals 80. Now I'm going to ask myself, is this reasonable? 60% of some number is 48. 60% of some number. So I do not know my number. I do not know what the number is. So I have some number, just to draw this. My value is x. I have some number, and 60% of it, which is just over half, the value of that chunk right here is 48. So they're asking for the whole thing. They want to know all of this. So is 80 reasonable for all of this? Yes, it is. So if you accidentally did 60% of 48, your answer would be smaller. And again, that would not make sense. So stop for a second and just see, is my answer reasonable? Anyone else is reasonable? More math. Let's keep going here. Select all the equations that represent the area of this rectangle. Okay, so 7 times 8. Now that feels fishy, but I'm going to try it. So 7 times 8. It would work if, oh yeah, 5 plus 3 is, totally works. Ding, 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 ding. Okay, 7 plus 5 plus 3. Okay, this is starting to feel like perimeter, but it's not even perimeter, so that does not work. Area is going to have some multiplying in there. Oh, we got some multiplying here. 7 times 3. So 7 times 3 will get me this area, but that 5 is not going to get the rest of it. So that does not work. How about this one? 7 times 5 times 3. Okay, when you're multiplying 3 numbers together, in a row especially, you're talking about volume. So that's not, we're not talking volume, we're talking area here. Ooh, 7 times 5. Ooh, this has potential. 7 times 5 is going to get me this. 7 times 3 is going to get me this. And if I add those together, works. Ching, ching. See, 7 times 5 gets some of it, but the plus 3 doesn't get the rest of it. A and E are my 2 answers. Well, let's keep practicing. This is all called the distributive property, and we're using area models to represent it, to help us see it a little better. So write 2 expressions. All right, this is going to be length times width stuff. So C times, I got my 5 plus my 2. Oh, my handwriting's a little bumpy here. Let me try that again. 5 plus the 2 plus the 3. That's one of them. Now we can do the area, which is that side right there, which is 5 times C. And we got this guy, which is plus 2 times C. And we got this one right here, which is plus 3 times C. And those are all my different pieces. Yes, a person could do C times 5. You can do that, but we want to start putting the number in the front and stop using, and then we're going to stop, no longer use the dot anymore. When you put a number and a letter right next to each other, number and a variable, it's called a coefficient. That number has a name now, it's coefficient, and the letter is all the variable, but that's multiplication. But C times 5 also works. So in the beginning phases here, you can use that. But they're my 2. Ding, 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 ding. Oh, we get to do another one. Distributive property. Only one of these works. Now, this is looking for the area of the shaded region. That's why we have subtraction going on here. But which one works? So this is saying I have 5, and I'm taking away A. So it's 12 times, which is good. I have the 5, and I'm taking away A, and this is the one that fits it. I have 5, and I'm taking away the value of A. And once I know A, then I can solve that. Yes. This other one here, that's A minus 5. That's going to move into probably some negative numbers, which is a thing. Negative numbers is a thing, just not for this situation. What do we got here? Did you press pause? You didn't. Press pause. Come on, just press pause. And then you work this out and come back to me. All right, here, let's see what we got here. I'm going to see if this fits. Okay, 7 times x, which is that. 2 times x, which is that. I'm going to add them together. Yep, that works. A works. X plus, okay, we're just starting to feel like perimeter again, but it's not even perimeter, so that so does not work. 9x, this would work if it's x times, and if this all the way across equaled 9, so 7 plus 2 is, yep, worked. Oh, and then it kind of fits here. 7 plus 2, that's at top, times x, which is on the side. That works. And look what we got here. We got 7 times 2 times x. Yeah, this smells like volume. Smelling like volume, which is not what we're doing. No way, Jose. Which one's equals 6c? Okay, 6 plus c? Yeah, no, that's not going to do it. C times c times c. Okay, there's a lot of c's going on. This is actually an exponent. So this is c to the 6th power, which is very different than 6c. So it's not that one. 1, 2, 3, 4, 5, 6. That's 6 c's, which is what this is saying. Once I know c, I want 6 sets of them, so that one works. Oh, 6 sets of c, that one works. 2 sets of c and 2 sets of c and 2 sets of c all together. You know what, that really is 6 sets of c, so that one does work. What we're doing on this one is we're just seeing if you're paying attention to exponents when you're supposed to deal with an exponent, and then when you're just dealing with groups of numbers. Ooh, a little matchy-matchy. How exciting. All right, what's going to go with what? All right, so this guy right here, this is going to be 5x, and that's going to be a 15, and it's addition, so pay attention to that. So 5x plus 15. Yeah, this one. All right, let's check this one. This x goes to this one, so that's 3x, and that's x, so it's 5x. I'm going to watch, make sure it's addition, so 3x plus 5x. 3x plus 5x. Ding, 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 ding. Let's do this one. 10, so it's 10x. 10y, and 10z, and gotta watch, make sure it's addition, because if they're sneaking in some subtraction down here, it wouldn't be true. So 10x, ding. So this last one goes, I mean, it goes right here. It has to, but let's check it. 11 times 3, which is 33x, and then 11 times 2, which is 22y, and check if it's addition. It is addition, and it's true. Again, some people just get going way too fast, and you miss the fact that this is addition, and I might sneak in a subtraction on you, which would not make it true. Like if this was minus down here, this would not have a match. You'd be like, this looks like it, but it's not it because of the subtraction. So be very, very, very careful. Select all the expressions that are equal to this one. Okay, let's try it. Whew. Okay, 4 times 3. 4 times 3, that's 12x. And 4 times 10 is 40. And I'm going to watch the addition. Yep, this works. I am going to watch the addition. Let's try this one. 3 times 4, okay, that's 12x. And then that's 30. Nope, I'm looking for 40. Doesn't work. 6 times 2x, 12x. So far, so good. 6 times 6. Okay, 6 doubled. No, 6 times 6 is 36. Too big. No, it's not too big. It's actually not big enough. But it doesn't work because I need to get up to 40. How about here on this one? 2 times 6, so we got 12x. Okay, and this guy 2 times is 40. So far, so good. I'm going to check addition. Addition. Yep. Ding. Works. This guy right here, so 12x, which is good. Addition, which is good. 12 times 4. Yeah, that's 48. That's too big. That's over. Over. So it looks like we just got 2. Speaking of 2, let's do problem number 18. The area of a rectangle is 6y and 24. What are the possible lengths and widths of the area? Interesting. Okay, so the width is half. So it looks like this. This is what they're talking about. They're saying 1/2 times, oh, that's terrible, 32y plus 48. That's what they're saying. So half of 32, right, am I doing the right thing? Yeah, half of 32 is 16, and half of 48 is 24. And I got that y here, and I got the addition going on. Oh, yeah, that works. Doesn't look like it does because of the halvesy, but it totally works. B right here is saying the width is 2 times 14y plus 22. So let's double 14. Okay, if you double 14, you're up to 28. Oh, they want 16. Doesn't work. I already know it doesn't work. Width is 2 times 8y plus 12. Okay, 2 times 8y is 16y. Oh, so far, so good. Plus, yep. And then 2 times 12 is 24. Ding, 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 ding. C works. Let's try D. This is saying 4 times 4y plus 12. 4 times 4 is 16y. Yep. Plus. Yep. 4 times 12. Yeah, that's 48. That's not what we're looking for. How about this one? 8 times 2y plus 3. 8 times 2, 16y plus 16y plus. So far, so good. 8 times 3. Ooh, that one works. That is 24. Ding, 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 ding. We got ourselves 3 answers. A, C, E. 19. Select all that are equivalent to 16. Okay. So 2 times 2 is 4. Because 2 to the 4th power is like saying 2, but I have like 4 of them and I'm multiplying together. Okay. 4 times 2, I'm up to 8. So far I have 3 of them. I need another set. Times 2 is 16. There's 4 2s, 16. That one works. Oh, 2 to the 8th power? That is 2 times 2 times 2 times 2 times 2 times 2. That's 8 of them. That is so not going to work. That number's going to be enormous. 4 to the 2nd power is actually 4 times 4. You know what that equals? Yeah, that equals 16. That works. Let's check out D. This one is 4 times 4 times 4 times 4. Way too big. This is 8 times 8, which is 64. And I want to get to 16. Yep, that's our... not going to work. Okay, if 8 times 8 doesn't work, then 8 times 8 times 8. 8 of those, that's going to be enormous. That so does not work. Select all of them that are equal to 4 to the 3rd power. Now, I'm looking through here to see if I can find 4 times 4 times 4, but I don't see any of those, so it must mean like equal, like it's a value. So let's find its value. 4 times 4 is 16 times another 4 is 64. So really, and there's 1, 2, 3. Okay, there's, yep, 4 to the 3rd power. So which one of these equals 64? Oh my goodness. So 2, we already did 2 to the something power already. So 2 to the 4th power is 16. So we already found 2 to the 4th power, which is 16. And we're going to take that times 2. 16, which is going to be 32. So that's the 5th power. And we're going to double that, which is the 6th power. So we're up to 6 2s now. 32 times 2. Oh, that's 64. This works. Ding, 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 ding. Okay, 3 to the 4th power. 3 times 3 is 9. Times 3, which I'm all the way up to 27. Times 3 more. 27 times 3 is like 81. Yep, nope, doesn't work. 8 times 8, that's 64. That works. 12, yeah, no, that's just 12. 64, just chilling here by itself. Yep, that works. And 81, that's a big no, because it's not 81. It's supposed to be 64. Oh my goodness, we're almost done. This is so exciting. All right, which of the following are ways to rewrite this using the distributive property? All right, we can rewrite this. So this one, let's write this out. So this is 4 times that side, so 4xy, plus 4 times 3, so 4, so that's 12xz. Is that what we want? 4xy and 12xz. That one works. That one works. This one right here. Okay, this is already 4 times 12. That's too big. Doesn't work. Let's do this one. X times 4. Oh, yeah, look at this. This is 4xy. And this is 12xz. And it's an addition sign. This one works. I got a z already. So this one here is a 4zx. Yep, that's not going to work. Too many. Yep, nope. Nope. And this one right here, that one works. This one works. Yes. All right, last one. I'm going to count those 4s. 1, 2, 3, 4, 5, 6. There's 6 4s here. So there's 5 already and 1 more. This works. This is 4 times 6, which doesn't work. 6 times 4, which doesn't work because that's saying something different. And this is saying, oh, there's the 4 6s. That one works. And this is 6 4. That one does not work. The person which ones are true and false. Okay. This is actually 8 times 8 times 8 times 8 times 8. Yeah, no. That's false. This is 8 times 8, which is, let me look at this one. 8 times 8, which is 64. And I'm going to double it. So that equals 128. Now, 2 to the 7th power, we already found 2 to the 6th power, way up here. Where's 2 to the 6th power? 2 to the 6th power is 64. So 2 to the 6th power is 64. And if I double that, I get 128. That is true. This is 5 to the 1st power, and it equals, oh, this one works. This one's true. This one works. Number 4, 7 to the 4th power is different than adding. This does not work. You know what? This one feels like it doesn't work. So this is 4, 1, 2, 3, 4, 5. This is 4 times 5, which is 20. And this is 1, 2, 3, 4. This is actually 5, and it's 4 sets, and that equals 20. Oh, you know what? These are equal. This is a true statement. This is a true statement. All right, what do we got? Almost done. Evaluate each expression. 3 to the 3rd power is 3 times 3, which is 9. And 9 times 3 is 27. So 8 plus 27 is 35. Got to do those we got to do those exponents first before we finish adding. This one is saying 7 times 4 to the 1st power is just 4. So 7 times 4 is 28. 3 to the 4th power is 3 times 3, which is 9, times another 3 is 27, times another 3 brings us all the way up to 27 times 3 is like 81. So 100 minus 81 will bring me all the way down to 19. 5 to the 2nd power is 5 times 5, which is 25. So 3 times 25 gets me up to 75. All right. Ooh, some fractions. These are going to be funky. All right, 1/3 to the 2nd power is actually 1/3 times 1/3, which is 1/9. So now I have to take 1. Okay, so now let's do here. So 27 over 1 times 1/9 is equal to 27 times 1 is 27. 1 times 9 is 9. 27 divided by 9, because fractions are division problems. 27 divided by 9, that's actually just 3. Yay. 4 to the 3rd power. Okay, so let's do this. 4 times 4 is 16. Times another 4 gets me all the way up to 64. All right. So I know that 4 equals 64. So 1/4 times 64 over 1 is 64 over 4. So how many 4s are in 64? There's a bunch. There's like 16 of them. So 16 divided by 4 is 16. Now this guy right here, we got to do what's inside the parentheses. So let's do that. So 1/6 times 12 over 1 is equal to 12 over 6. Oh, 12 divided by 6 is 2. Now let's deal with that exponent. This is saying, oh man, we got 2's all the time here. So 2 times 2 is 4, times another 2 is 8, times another 2 is 16. This lands at 16. Did we do it? We did it! Yay! Good job, you all. All right, I am gonna go and play golf with lemons, because why not? Actually, that doesn't sound like a really good idea, but I'm